Hello, hello, hello. Welcome to December's Ask Me Anything, all about CERs with data. It's been so fun to see the questions that have been coming in. Super excited to sort of address some of those and circle back to what we were talking about last week as it relates to helping our students be able to dig deeper and have more nuanced understanding of making claims from data or drawing conclusions from data, different pieces like that. So let's jump right in. And just as a sort of a reminder of where we're situated, each month we talk about a different topic, and December is all about conclusions and all about making claims and how do we help our students make those claims and draw those conclusions. And it all relates to this piece of helping our students work with data, to interpret data, to learn something, right? This is part of when we're working with data. There are always three realms, three things that we're doing with data. We are getting the data, we are exploring the data, and then we are inferring meaning from the data. That is the purpose. We don't just look at data to look at data. We use data the same way we use text and images. It is information that we can use to have deeper understanding, broader awareness, getting deeper into our content areas, different things like that, right? There's a purpose, there's a so what or for what that we are using the data for. And this, the conclusions and claims piece, is the final, like, oh, we're finally getting to that purpose of what we're doing. And there are many steps and many things we do along the way, but this is the one that we were focused on this month, right? And last week we had a great session where we dove into all different kinds of strategies we could try in different ways that we could get at these different strategies to help our students build their understanding and their ability to work with data in order to make a claim or draw a conclusion from it or synthesize what they are learning from all of their data. So we talked through how to practice pulling evidence from data, how to help students sort of practice that pulling the evidence by having them not only think about what they can say from a data set or a data visualization, but also what can they not say. And this helps them deepen their understanding of what is evidence, what can count as evidence, what are we going to use, but also sort of situating in that. And so therefore, what is my inference space? What's the boundary of what I can claim from these data based on what I have here? It's a way to deepen how they look at the data. We also talked about the strategy of having students support and refute claims provided by available data. Again, we often have students look at data and identify a claim, something they can say, or what the evidence supports. But as our novices are working to build this skill, and all of our students are novices, they need a little, sometimes it can be helpful to provide different wraparound supports for them. Don't mean to use the word support multiple times, but different ways to help them build that skill and build that muscle memory of what does the evidence support. And we talked about different ways to have students do that, either by asking sort of what is refuted, providing claims, asking how the data or evidence refutes those claims, providing a range of claims that are slightly off and they need to adjust and modify those claims so that they are better supported by the evidence. All of these different things, the what can and cannot say and support and refute, right? We talked through various ways that you could get at them, but they're all working at getting students to dig deeper and pause and really look at and think critically about what they are working with in the data, what the data actually include, what they don't include, different pieces like that. And those are key steps that our students need to go through so that they can build up the mental model, the pathways to be, okay, I'm looking at data, it's coming across, what am I thinking about? What can I say? What can I say? How is this claim supported or not supported by the data that I am seeing or the evidence that I'm seeing in the data? So those were two of the strategies. And then we talked about sort of thinking about how to deepen and broaden their reasoning by going at it from a couple different perspectives. And so we addressed a bunch of questions last week, but also excited to receive all the questions that have been coming in from the last week to our Ask Us tiny URL. If you have questions, keep them coming. We will post responses and get them out to the community in different ways like that. But really thinking about how do we set our students up for success with drawing data conclusions, and especially around this like adjusting how we ask them to practice. We talked last week about how we strengthen our arm muscles by we can do pull-ups and we can do push-ups and we can do bicep curls and all these different things. And those are all different ways to strengthen our arm muscles. And we don't just do one over when we're strengthening other muscles. It leads to overuse and fatigue and potential injuries, things like that. It's not going to happen to our students as they're working with data, but it's a similar thing of practice and iteration, and practice from different perspectives and different angles actually strengthens their understanding and their working through it. Okay, so with all of that, let's jump into some of the questions. So one question that we got was we talked about how working with developing a CER from data is different than prose. And I just talked through this quickly last week, and we got a couple different questions that were coming in about, can you say a little bit more about what these different pieces are? So I just wanted to dive into that a little bit more here. So when we are making a claim or drawing a conclusion, when we are reading prose, it often follows this linear format of we read the prose, we look at it, we can identify the thesis statement of the author or the thesis, the topic sentences of the different paragraphs, depending on what level of claim and conclusion we are drawing, but we are reading through the prose kind of in a linear format, and then we are digesting it, thinking about what that CR is. It's sort of lined out in this linear format that we use when we write our prose, and then we can get to the end and we can think about what is our conclusion or the claim that we can draw from those prose, and then we can connect it back to the content. So a lot of our data rich or data experiences for our students in the classrooms also follows this linear format of we provide data to our students, usually in some sort of visualization, and we are asking them to look through that and then develop a claim or a conclusion from the information that they've just looked at and connect it back to the content. But the tricky thing is that this linear format is not actually, it turns out, the way that we process data, even ourselves as experts. We do this subconsciously, so we don't even really realize it. We are simultaneously intersecting all three of these, the content, the visuals, and the data. As we are processing it and looking at it and making meaning of it, data sets and data visualizations do not follow a linear format. And so it's not too surprising that therefore our brain works with it a bit differently. And we talked about how it's these intersections of these three pieces coming together, these connector pieces, where cognitively, that's what we're working on with students. And this is where a lot of the questions came in of like, can you say more about what's going on in those cognitive steps? So happy to. Just a quick sort of, the content is the for what. It's what our learning objective is, what we're working on in our classes, and what we're trying to get across for our students. The visual is how we're engaging with the data in terms of, is it a data table, an interactive data table? Is it a graph? Is it a chart? Is it a map? Different things like that. And then the data are the actual values. That's the with what. What are the actual observations and measurements about the phenomenon or the system that we have been exploring or that we are exploring through the data set? So let's think about these intersection points. So when we are sort of intersecting the content and the visuals, that's often what I call the engage or the orientation or the sort of pause and get a sense of what's going on the page step, where we think about things like, what's the context that we are looking at? What kind of data are being used? What's the shape, size, and or nature of the visualization? What kind of visualization is it? Those are two different things. What are the parts of the visualization? What are on the axes? What's in the legend? Different things like this. So this is really, as one teacher described it a few years ago that we were working with, he's like, I have my students introduce themselves to the data visualization and or the data table, and vice versa, get that back. It's sort of that initial introduction, like what, just sort of what's there, what are we looking at? And that helps us get a sense of the visual, however the data are, we're engaging with them visually, and the content, right? The context, what are the data? How are they collected? Different pieces like that. That's a really helpful first step. And then we can move on to what we call the analyze step, where we are thinking about sort of not just superficially, like what's the ink on the page, but now we're diving into the actual values of the data, not just how they're visually structured, but what's actually in the data. As we can, we can see it in the visual and we're looking at those values. So this is where we can start to ask questions of like, what are the data showing me in terms of where they actually are on the page, what the values actually are? What are the ranges of the data? For our older students, are there outliers? For our younger students, are there gaps or are there values that are really different than everything else? How do the variables change? Do they change? Good first question. Do the variables change? How do they change? How do they change in relation to one another? How do different groups compare within the actual values? And then what is the pattern? How would we describe what's going on in the data? Or how would we describe some of the features that we are seeing in the data? So this is really when we're sort of moving beyond that superficial kind of what kind of data is it to thinking about, but what are the values and how do the values of our different data components relate to one another as part of the larger data set that we are working with? And with that, then we can move into the interpretation phase where we're thinking about the values of our data and how that relates to the context or the content of what the data are about. This is where we start to pull off the page and think about, so what does it mean? Therefore, if one value as one variable increases, so what does that mean? Oh, so there's this increase, as one increases, the other increases. So if I were to collect another data point about one, the other one would go up. So they both go up together or they both get smaller together. How could that be? Like mechanistically, what would cause that to happen? How sure are we in the pattern? This is a big one, right? Because just because we see something in the data doesn't mean that necessarily is a picture of everything that's going on in the system or the phenomenon. That's why this how could it be is such a critical sort of question that we ask at this step of like gut check. Does it make sense? How could that actually come about that those two things could be increasing together? And therefore, do we feel like we've got a good sense of everything that's going on? And therefore we could be pretty sure that this pattern that we're seeing is actually giving us a description, is a good model for what's going on in the world. It's deepening our understanding of that phenomenon or the system. Or are we like, there's some gaps in our understanding. There's some things that don't quite make sense. What does this all mean to me in terms of taking in the information about the pattern and all those components? And how does it relate to things I already know? And so we as experts do these three steps, the engage, the analyze, and interpret, pretty much kind of instantaneously or within a few seconds. We spend a bit of time on engage. We work really quickly through analyze and we jump deep into interpret. This is where we love to sit as experts because we're like, ooh, why? Or how could that be? Or how does it relate? Or what does that tell me about this? And that is wonderful and fantastic. But for our learners, we need to make sure we're sort of slowing it down, helping them slow down and do each of these three cognitive steps, because that's actually what is needed for our students to be able to make a claim that is well supported from the data about what's going on in the data. If we jump through these steps too quickly, or if we just sort of pull them to the claim or pull them to the interpret out of the gates, then there's a rub because they haven't gone through all of these cognitive steps of really syncing and connecting those different pieces. So hopefully that was helpful as to why, when we're trying to sort of help set our students up for success with claims evidence reasoning or CER with data, we don't want this linear model of we just give them the data and then we expect them to be able to come up with a claim and connect it back to the content. But instead, we sort of think very strategically on what questions we're asking and how we are stepping them through so that we're creating opportunities that our students are getting to do all three of these cognitive components as they're working with data, is thinking about data before we jump to the what's going on in the claim. Hopefully that was helpful. This relates to another question that came in, which was thinking about this. Okay, this is a lot of things that are going on before we actually get to the claim, but it's called claims evidence reasoning. And so what's going on and da 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 da. So let me just be totally transparent and out front. Claims evidence reasoning is a fantastic approach to writing out our conclusions that we have drawn from data once we have drawn them. In fact, claims evidence reasoning and rebuttal as a structure was specifically designed to help our students deepen their ability to argue with evidence, how to construct that explanation, aka both of those things happen after they have done the exploring, after they have made meaning from it. And so absolutely CER is how we write up our conclusions as they are coming through. If you look at any peer-reviewed published paper that is working with data, they tell you the claim, the thesis up front, and then they show you all the evidence, thank you results section, and then they explain all of their reasoning as to why their claim, why their thesis is supported by the evidence, thank you discussion section, right? So this is a very efficient way to share information once we already know what we want to share. But it is not actually how we determine what we want to share or what we want that claim to be. No one who works with data professionally as a job jumps to the claim initially. Why? Well, because it sort of reinforces confirmation bias, or sort of leads you to be like, is that really what the evidence is showing us? Or is that just what we wanted the evidence to show us? And so we talk here a lot at Dataspire and all of the sessions that we sort of put together and how we kind of bring it to mind is first, we want students looking at the evidence. We want them in the data. We want them making sense of it, as we just talked about, through that structure of like digging into not only looking at it, but then thinking about, so what are the patterns and what are the features, aka the things that could be our evidence components. And then from there, there's two different ways. Some of us feel more comfortable being like, okay, I've got my evidence and I'm going to reason what that could mean. And that will help me actually identify my claim. And others of us are, okay, I've got my features and my patterns and it's just jumping out like this is my claim. And then I want to reason and put together like why that claim is specifically supported by those pieces, those lines of evidence, but really starting with that evidence forward. And if you take this mindset, either the ERC or the ECR, as opposed to the CER as the sequence for the initial learning and making sense of, then the components that we were just talking about of what it actually takes to develop a CER, develop a conclusion from data, make a lot more sense as to how it can all piece together and work. So hopefully that answered some of the questions as to like, this is a lot. How do we actually then still get them to a CER? Well, they're doing all the pieces as they're going through this part. So by the time you get to the CER, they've done all the work, right? They've looked through all the evidence and they've thought through the reasoning in the interpretation piece. And then they're off to the races. They're golden. Then it's just an execution on how to actually communicate what it is you'd like to communicate. Okay, one last big question that we got. There was some question of kind of how do we help our students think about claims, think about working with data when there's two different ways that we go about making claims. Or this came through of a like, they always want to do a controlled treatment, but that doesn't quite work. Or how can we actually do a study if we don't have a control? Things like this. Well, there's always things we can control. It just doesn't always neatly fit into the box of a sort of lab investigation where we can control everything. And just a really great reminder that there are two different ways that we can make claims from data. We can make deductive claims, where we have a hypothesis, then we go out and we collect evidence, and we look at that evidence in terms of whether or not it supports or refutes the hypothesis. You can think about this as we're sort of reasoning down from the hypothesis through the evidence down to our understanding. This is the vast majority of in-class sort of labs in science class. But it is not the only way that we work with data in social studies, in math, in science, out in the world, where we're working with data, where oftentimes we also make inductive claims, where we have evidence and then we draw conclusions from those evidence. So in essence, we call this sort of reasoning up, where we are coming from the evidence and we're identifying the claim that is coming through on the evidence. We don't necessarily have a prior hypothesis as to what it is we think we will find. Okay, just a few things. We talked a lot about this CER, arguing from evidence or constructing an explanation. I highly encourage you to jump in and take a look at it. They are similar, but not quite exactly the same. And so we put together this sort of cheat sheet of what are the differences and how to set that up for your students. And as always, next month's strategy share out. This one actually is for admins. We're focusing on admins. Super excited to talk to you all. So share this with your admins, share it out. We would love to connect with them, where we're going to be talking about fueling collaboration with data, sparking engagement through department conversations. We love talking to you, teachers. We also love supporting admins as they go through and do their work. So with that, thank you. I hope you have a wonderful holiday season. Happy New Year. We'll see you in 2027. Thank you for everything that you do for students. Until next time, stay curious and keep exploring your data. Bye.